Welcome to video lecture. Myself Ashwini R.K., Assistant Professor, Civil Department, Rogni College of Engineering and Technology. Today we are going to see about separation of boundary layer. When a solid body is immersed in a flowing fluid, a thin layer of fluid called the boundary layer is formed adjacent to the solid body. In this thin layer of fluid, the velocity varies from 0 to the free stream velocity in the direction normal to the solid body. Along the length of the solid body, the thickness of the boundary layer thickness increases. The fluid layer adjacent to the solid surface has to do a work against the surface friction to expense of the kinetic energy. This loss of kinetic energy is recovered from the immediate fluid layer in contact with the layer adjacent to the solid surface through momentum exchange process. Thus, the velocity of the layer goes on decreasing. Along the length of the solid body, at certain point, a stage may come when the boundary layer may not be able to keep sticking to the solid body if it cannot provide the kinetic energy to overcome the resistance offered by the solid body. In other words, the boundary layer will be separated from the surface. This phenomena is known as the boundary layer separation. The point on the body at which the boundary layer is on the verge of separation from the surface is called as the point of separation. Effect of pressure gradient on boundary layer separation. The effect of pressure gradient on the boundary layer separation can be explained by considering the flow over a curved surface ABCSD as shown in the figure. In the region ABC of the curved surface, the area of flow decreases and hence the velocity increases. This means that the flow gets accelerated at this region. Due to the increase of velocity, the pressure decreases in the direction of flow and hence the pressure gradient dP by dx is negative in this region. As long as the dP by ds is less than 0, the entire boundary layer moves forward as shown. Region CSD of the curve, the pressure is minimum at the point C along the region CSD of the curved surface. The area of flow increases and hence the velocity of the flow along the direction of the fluid decreases. Due to decrease of velocity, the pressure increases in the direction of flow and hence the pressure gradient dP by dx is positive or dP by dx is greater than 0. Thus, in this region, the CSD, the pressure gradient is positive and the velocity of the fluid layer along the direction of flow decreases. As earlier mentioned, the velocity of the layer adjacent to the solid surface along the length of the solid surface goes on decreasing as the kinetic energy of the layer is used to overcome the frictional resistance of the surface. Thus, the energy of the layer is used to overcome the frictional resistance of the surface. Thus, the combined effect of positive pressure gradient and surface resistance reduces the momentum of the fluid. A stage comes when the momentum of the fluid is unable to overcome the surface resistance and the boundary layer separates from the surface at the point S. Downstream the point S, the flow is taking place in reverse direction and the flow gradient becomes negative. Methods of preventing the separation of boundary layer. The following are some of the methods generally adopted to retard or arrest the flow of separation. Streamlining the body shape, tripping the boundary layer from laminar to turbulent by provision of the surface, sucking the retarded flow, injecting high velocity fluid in the boundary layer, providing slots near the leading edge, guidance of the flow in confined passage, providing a rotating cylinder near the leading edge, energizing the flow by introducing optimum amount of swell in the coming fluid. Thank you.